So hi and hello. Welcome to our channel named Algo Exploration. My name is Sami. Now in today's lecture we are going to see that how to find a unique element among duplicates element. Okay. So we will have an array. Now here we are going to have 4, 1, 2, 1, 2, 4, 7. Okay. Let's name this array as an A. Okay. And we can see that every element is duplicate except 7, right? So here 7 will be the answer. Or let's say we have to return 7. Let's take one more example. Here also we can see that in the second example, 8 is a unique value. Apart from that, every element is duplicate, right? So here we have to return 8. And in the next example, we have to return 22 because 22 is a unique element, right? So this is the problem. I hope you got it. So let's see that how we can solve this problem. But let me tell you that we have started a series on DSA. If you know the fundamentals of DSA but getting stuck while solving the DSA problem, this series will be helpful for you. If you're preparing for placement and interviews, you can visit to this playlist. The link is in the description box. Thank you. Now let's see how we can solve this problem. Okay. So approach one. So here what we can do, uh, let's take an array. So a, so here we will have 4, 1, 2, 1, 2, 4, 7. Okay, we will sort it. So after sorting, it will look like this: 1, 1, 2, 2, 4, 4, and 7. And we can simply compare the adjacent element. Okay, so by comparing, we will get to know whether which element is unique. Okay, so since this is a basic approach, okay, so I will not give the pseudocode. You can try it by yourself. If you are not able to come up with the approach, don't worry, you can watch it in the description section. Okay, so for sorting an array, it will take time complexity of n log n, and since we are comparing it, it will take n. Okay, so here the dominant is n log n, so the time complexity is order of n log n. And if you're going for sorting, if you're going for the quick sort, it will not take any space, but if you're going for the merge sort, it will take a space. So let's say if you are going for this quick sort, the space complexity will be order of 1. Okay, this will depends. Now, so let's see that how we can optimize from n log n to n. Okay, so let's see the approach 2. Here what we can do, we can create a frequency array. Let's say, so for every element we can have the frequency, that means the occurrence. Okay, so we can take the help of HashMap. I hope you know that what is HashMap. So inside this HashMap, what we will be storing, the frequency of each and every element. So for 1 the frequency is, for element 1 the frequency is 2, for element 2 the frequency is 2, for element 4 the frequency is 2, and for element 7 the frequency is 1. Then we will simply iterate for each and every element, and we will search that what is the frequency of that element. When we are reaching at element 7, we will get to know the frequency is 1, so we will simply return element 7. So let's see the pseudocode for this. First of all, we have to create the hash map. Okay, so I hope you know that how to create a hash map. So I'll simply write in a comment, create a hash map. Okay, now we have to store the elements and its frequency into the hash map. Okay, so we will be using for loop int num. Here I will be using enhanced for loop. So a, so a is nothing but the array name. Now HMap. Here the hash map name is HMap dot put num comma HMap dot get or default. If you don't know what is get or default, you can simply Google it. Num comma 0 plus 1. Now this will store the frequency of each and every elements. Okay, till this point we have just created a hash map and we have stored the elements and its frequency. Now we will be having one more for loop. Here also I will be using enhanced for loop. Now first of all we will find the frequency of that element. So to find the frequency we will be using hmap.get method. Here we will be passing num. Now we will be checking if frequency is equals to 1, then only we have to return the num. Otherwise we have to move forward. So the question is actually saying that it is guaranteed that unique element will present. Okay, so that's it. So we know that since it is guaranteed that unique element will be present, so we will simply write 0 here. Okay, even though this statement will never be executed. Okay, so let's talk about the times complexity and the space complexity. This loop will take order of n time, and also this loop will also take order of n time. So n plus n, that will be 2n, that will be boils down to order of n. Okay, and if we talk about the space complexity, we know that we have taken the extra space, that is hash map, so it will be order of n. Okay, so here this is the overhead now, right? So let's say that how we can optimize the space complexity to order of 1. Okay, there is one more approach. In that case the time complexity will be order of n and the space complexity is order of 1. Approach 3. So here we have to learn some basic properties of XOR. I hope you know that what is XOR. Okay, so if I talk about it, we will have two inputs A and B, and the symbol for XOR is look like this. Here we will be dealing with only two inputs, so the combination will be 0 0 0 1 1 0 and 1 1. Okay, here if the inputs are different, then only the output will be 1. Okay, otherwise it will be 0. Okay, so this is the truth table of XOR. Now let's take one example. So if I have value 3 and if I do XOR with 3 only, okay, so the binary representation of 3 is 0 1 1. Okay, and since we are doing XOR, it will be 0 1 1. Okay, now if we do XOR, it will be 0 0 0, right? So if I take any number, let's take A, and if I do XOR with A only, my answer will be always 0, right? So let's take one more example. 3 XOR 4 XOR 3. Now I have to do XOR of every elements. So if I do XOR of 3 and 4, it will look like this. The binary representation of 3 is 0 1 1, and the binary representation of 4 is 1 0 0. Okay, if I do XOR of this, it will be 1 1 1, right? Now the 3 is remaining, so let's take 3 0 1 1, and I have to do the XOR again of these two. Okay, so this will be 0 0 1. So the decimal representation of 100 is 4. Okay, so if I do the XOR of 3 4 and 3, the answer will be 4. Okay, so here we got to know that from this, if I do the XOR of same element, my answer will be always 0. So we can say that this and this will get cancelled. All right, the answer will be 4 only. Okay, so in this way we can solve this problem. Let's take one more example. It is 1 3 2 2 3, and I have to do XOR of every elements. Okay, so let's start from the top. So 1 XOR 3. So the binary representation of 1 is 0 0 1, and the binary representation of 3 is 0 1 1. If I do XOR, I will be having 0 1 0, right? Now I have to take this element 2. So the binary representation of 2 is 0 1 0, and if I do XOR of this, since every bits are 0, every bits are same, it will be 0. Let's consider the another 2. So 0 1 0, and XOR will be 0 1 0, right? Now let's take the last element, which is 3. So 0 1 1, in if I do XOR, I will be getting 0 0 1. So the decimal representation of this is 1, right? So if I do the XOR of every elements, I am getting the answer as 1. Okay, so in short we can say that this and this are getting cancelled, this and this are getting cancelled, the remaining number is 1. Okay, so this is the unique element. From here also we got to know that 4 is the answer, so 4 is the unique element. By seeing this behavior, we will build our pseudocode. Okay, so we will have the elements present in an array, so we will simply run one for loop. Here I will be using enhanced for loop, int num colon a. Okay, initially variable answer will be 0. Now answer XOR equals to num. That's it. At last, simply return answer, and we are done. Okay, so let's talk about the space complexity first. So the space complexity is, since we didn't take any extra space, so it will be order of 1. Okay, and if you talk about the time complexity, it will be order of n. Okay, because there is a single for loop which is running for n time. Okay, so this is the time complexity and space complexity. So in this way you can solve this problem. I hope you got this. You can try run this pseudocode by yourself. So that's it from my side. I'll see you in the next video. Till then, keep practicing. Thank you.